Good morning, everyone. I am Dr. Vijay Bhandari, Associate Professor in SIIT CSE Department. So let's start with the Python recursion. Now, so let's move in next slide. The term recursion can be defined as the process of defining something in terms of itself. In simply words, it is a process in which a function calls itself directly or indirectly. Right? So in this process, we know that a functions can call other functions. It is given possible for the functions to call itself. These types of constructs are termed as a recursive functions. So in this, there is advantages of using recursions and disadvantages of using recursions. So what are the advantages of it? So a complicated functions can be split down into a smaller subunit problems utilizing recursions, right? Sequence creation is simple through recursions than utilizing any nested iterations. Third is recursive functions render the code look simple and effective. So that's why the advantages of using recursion. Now we'll discuss about the disadvantages of using recursion. So a lot of memory and time is taken to recursive calls, which makes it expensive for use. Second thing, recursive functions are challenging to debug. And third, the reasoning behind recursion can sometimes be tough to think through the process. So that is the disadvantages of using recursion, right? Now we will discuss about the syntax of recursion. So first we define the class of functions, right? And we can define recurse, right? Then we can call it recursively, and again we call it recurse functions. We can call the methods. So that is the example of a recursive functions to find the factorial of integer in next slide, right? So what it does, the program to print the Fibonacci series factorial numbers, we can do sub programs based on it. So we will do some program based on the recursive function so that you can explore into more, right? So now let's start with the functions. After that, I will tell you about the tail recursions. So please request to all, please open your ideally so that we can perform the programs in PyCharm, right? So yeah, here I am printing the Fibonacci series, right, up to n terms, right? So first I write here what I am going to write the program. So it will print the Fibonacci series up to n terms, right? Now, so we are first we will create the recursive functions, right? So what we say is here, we will create the recursive functions. Now I will define here, I will create the class of recursive functions, right? So first I will create class recursive functions. So recursive Fibonacci series. I will take some argument here. Now enclose with the colon. So don't forget to add a colon at the end of the class when defining the functions. Now I will use now here if n is less than is equal to 1. So if you have don't know about the control structures, if else conditions, so you can just go through my let video lecture videos. You will find all the lectures of if else lecture 8 and 9, right? So if n is less than is equal to 1, so it will return n, right? Is that clear to everyone? Now I will use else. If n is less than is equal to 1, so return n, otherwise it will return recursive Fibonacci n minus 1. Now I will use here plus again recursive Fibonacci n minus 2. So everyone knows what is the Fibonacci series and how it executes, right? And at the end of things, I will add the parenthesis, right? Now I will use the next terms and terms. N terms is equal to 10. So I am taking the terms 10, right? So up to 10, it will print the Fibonacci series. So now I will check. Now I will check if the number of terms is valid, right? So I will check if n underscore terms is less than is equal to 0. Then I will print invalid input. Please input a positive value, right? Now I will again here I will give the conditions on that. So don't forget the adding the colon after else, otherwise it will give you a syntax error, right? So print Fibonacci series here, and you can just add column it inside the parentheses. Now I will use for I in range and terms, right? Here I will use print recursive Fibonacci series. I will insert I, right? So this is the program of to print the Fibonacci series. So first I use the creating the functions, right? Now I will I'm creating the if else condition. So if n is less than or equal to 1, so it will return n. Suppose it is giving the 5, so 5 is less than or equal to 1, so it is, and the condition is failed, so it will return recursive Fibonacci n minus 1. So 5 minus 1, 4, plus recursive functions 5 minus 2, right? So this kind of things it will be done. So after that we are taking the n terms of tens, right? So check if the number of terms is valid. So again it will check if n number of terms is less than or equal to 10, less than or equal to 0, so it will print invalid input. Please input a positive value. So else we go it go to the else loop, and then else condition, then it will print Fibonacci series. Again I will I am using here for. So for I in range n terms. So how did you take a number of n terms and 10, so it will print recursive functions number of 10. So it will generate the Fibonacci series in the terms of right. So here I run the program. So here it is I think unmatched some syntax error, right? So return recursive Fibonacci n minus 1. So here I have close it, right? So it will giving the error. So this is the output of your program. You can see just 0, right? You can check with the program 0 less than or equal to 1. So 0, 1, 1, 1 is equal to 1. So it will print 1. After then 2, 3, 5, 8, 13, 21, 34. So you have to check the logic of Fibonacci series if you don't know. So first you have to find the Fibonacci series. Use your copy and pen and write down the Fibonacci series. What is the logic of that? Then you can jump into the programming part in Python, right? So it will be more easier to you, right? Let's move to other part, tail recursion, right? So what is the tail recursion? So I will explaining to you here. So hopefully you have understood the Fibonacci series in Python using the recursion, right? So here tail recursion in Python. So what is the tail recursion? So how we use it, how is it works? So unique type of recursion where the last procedures of a function is a recursive call. The recursion may be automated away by performing the requests in the current stack frame and returning the output instead of generating a new stack frame. So the tail recursion may be optimized by the compiler, which makes it better than non-tail recursive functions, right? So some programming languages are tail recursive. Essentially, this means that they are able to make optimizations to functions that returns the result of calling themselves, right? Now, if you have understood the tail recursion, so I will tell you the I will give you the one scenario, right? So is it possible to optimize a program by making use of a tail recursive function instead of non-tail recursive function, right? So here, considering the functions given below in order to calculate the factorial of n. So we can observe that the functions looks like a tail recursive at first, but it is a non-tail recursive functions. So if we observe closely, we can see that the value returned by recurse facto of n minus 1 is used in recur facto of n. So the call to recur facto n minus 1 is not the last things done by the recurse facto, right? So this is the tail recursion that is used in many concepts, in many programming concepts, right? Here we can take some example of that, right? So the tail recursion is also kind of that recursion that I have already told you. So but it will make the return value of the recursion call as the last statement of the method, right? And in the traditional recursion, what do we find there? Calculations will happen after the recursion call, while the calculations will occur before the recursions call in the tail recursions. So here the traditional tail recursion and tail recursions. So recursion is frequently adopted patterns for solving some sort of algorithms problems which need to divide and conquer big issues. So that was the advantages of that, which I have told you. But the same issues, for example, calculating Fibonacci series and Fibonacci, accumulating sum and calculating the factorials. In this kind of issues, recursion is more straightforward than their loop counterpart. So further, recursion may need less code and looks more concise. That is a main benefits of recursion, right? So the same can be done using the traditional recursion way. So there is, I'm telling that every recursion problem can be solved using loop with the cost of writing more difficult to understanding the code. So everything is fine. But if the recursive calculations becomes too many and there is a potential of stack overflow issues, so this is because when carry method invoked with step like temporary variables, intermediate values to be stored there will be a stack created for it. So the intermediate value will be used to calculate the final results when the recursion call returns. So here you can see how the calling to return factorial n, and last thing is done by recur factorial. So when a recursive call occurs, there will be intermediate call occurs, value stored for each recursive call until the stop conditions reaches. Unfortunately, a modern interpreter or virtual machine will often have a stack limit, which limits the number of stack created. So if this limit is exceeded, so there will be a stack overflow error or similar happening, right? So that's why I have taken the example in starting of the this session. So hopefully this will be more clear to you, right? So stack flow over, that is we can call tail recursion, is also a kind of recursion, but it will make the return value of the recursion call as the last statement of the method that I have shown you, right? So this will make the calculations occurs before the recursive call, and hence there is no need to keep the stack to store the intermediate values when it is moves to next recursive call. So do hands on that. If you have any doubts, so please put your query on the chat box. Thank you. Goodbye. See you.